In rural areas, the infrastructure you would need for a terrestrial network is sometimes not economical. You would need to connect cell phone towers hundreds or thousands of kilometers over mountains or potentially crossing rivers and seas. Loon has decided to take a terrestrial infrastructure and sort of lift it up to the stratosphere, taking the most essential components, that is the antennas, and putting them on a balloon. In 2013, we did our first proof of concept test in New Zealand. A lot of the equipment was early prototype. It certainly was not a solution that you could scale up to millions of people. After the New Zealand experiment, we focused now on a scalable, deployable, worldwide solution. First, we needed a very reliable and robust high-throughput link to the existing internet. We beamed that signal up to the balloon through ground stations where the terrestrial internet network sort of ends and Loon starts, connecting the telcos up to the balloon. The balloon is not stationary, it's actually moving across the sky, so you need your antennas to be tracking that balloon continually and to be a high-throughput, reliable link. Once you get the data from the ground station up into the balloon, you need to connect multiple balloons in a chain in order to get the signal to where it needs to go. Sometimes hundreds or thousands of kilometers away from the ground station. So the balloon-to-balloon links are a really critical element of the Loon network. You can't string fiber between balloons, so the next best thing is to just beam the signal using lasers. You have these two free-floating platforms that are kind of swaying and bobbing freely. A dance, if you will, between the two balloons where the two lasers are trying to keep the beams locked onto each other as they drift in the sky. Everything has to be so precise and well-aligned to be able to provide reliable and robust connections. We've established gigabit per second connectivity between the balloons up in the stratosphere, hundreds of kilometers apart. Getting the signal down to the user. We're using LTE, so you could just use the same mobile devices used today to get service whenever there's a Loon balloon floating by. All of this technology coming together will ultimately allow someone who could be thousands of kilometers away from the nearest ground infrastructure to have access to the internet.
2, 1. Stand up.
For Loon to provide real continuous coverage. We're just transferring the signal from one balloon to the next as they pass over a stationary recipient. And so by having this continuous flow, we're always filling in the area that we need to provide the service to. And the biggest hurdle for a balloon is the wind. Once you've inflated the balloon, it gets quite large on the ground and acts as a large sail. It would catch the wind, and it was really hard to control it. So then you try to find locations around the world that had zero wind. But then you're limited in scope because you can't find these perfectly wind-free zones that provide access to the location where we want to provide internet coverage. And then for a given launch site, the ideal wind conditions would only exist for a very short period of the day, thus limiting the number of balloons we could get up in that period of time. We wanted to do something where we could launch one every 20 minutes. And so we needed to rethink how you would launch a balloon. We wanted to develop a launch system that would allow us to block the wind as much as possible, and it could launch balloons from a number of different remote locations and be nimble enough to deploy into a new area as we expanded the program.
We went into a very controlled environment and launched many balloons and measured all of the aspects of that launch. And then from there we developed our tooling in order to guide that motion. The auto launcher was 45 feet wide and 55 feet tall. The system is the 4-tired steerable gantry crane, and we outfitted it with hangar doors that allows it to become a wind block. It's a highly customized piece of equipment. There's nothing else like this in the world. We lift the balloon right out of the box, so we don't ever have to do any extra handling to the balloon. We have jib cranes to lift up the balloon at the top of the balloon to secure it while we're filling it. The wind does not bother the team because we have the ability to steer the crane so we're always downwind. And when we're in the right wind pattern, we lift the entire perch up, and then we angle the perch, and then we launch the balloon. So where we had 16 people launching a balloon, we now can do it with 4 people, and we can do it in a very short period of time. We can now launch at will instead of at will of the weather, and we can launch in a consistent manner. So we can keep a continuous ring of balloons that circumnavigate the globe.
The altitude that we fly at is actually above 99% of the atmosphere, which means that we have a lot of the same physical challenges as flying in outer space, and yet we still have to deal with the chaotic nature of the wind patterns. We need to know what the winds are in the stratosphere so we can surf those winds in order to go different places. We've been using some wonderful data we have from the National Oceanic and Atmospheric Administration, which gives us their best predictions of which directions the winds are blowing up in the stratosphere. They get their data from things like weather balloons, but as a weather balloon goes up, it gets larger and larger until eventually it pops. So the amount of time it spends in the stratosphere is pretty limited. In comparison, we'll have a fleet of balloons that are in the air all the time. And of course, we have GPS, so we can see which ways the wind is blowing us. And so we'll have a very rich stream of data coming into our system. You can kind of imagine putting a whole bunch of rubber ducks on a lake or an ocean and watch where they float to. You'd get a very good idea of what the water currents are doing, whereas our balloons would show you what the air currents are doing. So this simulation shows how we use the wind data to predict a balloon's trajectory. In this video, the red dot in the center is the balloon, and the arrows around it are the predicted wind field. So you can see as the wind field changes, the red arrow shows the velocity of the balloon as it travels through this ever-changing wind field. One question you might have is, are our balloons actually flying at the same speed as the wind? And it turns out that we can tell that they are because we've actually flown microphones on our balloons, and it's very quiet when we're flying in the stratosphere. That tells us there's no wind rushing past. Right now, we're only flying a few balloons, but we're already gathering a lot of really exciting data that's helping us understand the stratospheric winds better. And as we have better understanding, that's enabling us to fly more balloons with greater confidence and provide ourselves with even more data. And so we have this ever-improving understanding of the stratosphere. We've actually been talking to NOAA and working with them to feed some of the data from our balloons back into their models. And as our fleet comes fully online, we'll be able to significantly improve the quality of the wind predictions that NOAA is able to provide to others as well.
The goal of Project Loon is to bring internet to the almost 2 out of 3 people in the world who don't have internet access today. And we're doing that using high-altitude balloons.
3, 2, 1.
The very first tests we did showed that it could work. So we began to think, wow, we're going to need to have a manufacturing system that can manufacture many, many of these balloons. We're going to need to have a mission control system that can keep track of the balloons. We're going to need to have an operations team that can launch these balloons and then recover them when they're ready to come down. So each piece of the process got to be bigger. It had to scale up. It was pretty challenging, getting the balloons to be more durable and more long-lasting. For a while, many of them leaked for some reason or another, and they would come down over the course of a few hours or a few days. It was like a detective job to figure out what was introducing tiny leaks. Now our balloons last over 100 days. At first, it would take us 3 or 4 days to tape together a balloon. Today, through our own manufacturing facility, the automated systems can get a balloon produced in just a few hours. We're getting close to the point where we can roll out thousands of balloons. In the beginning, it was all we could do to launch 1 balloon a day. Now with our automated crane system, we can launch dozens of balloons a day for every crane we have. To steer 1 balloon left or right, you actually go up or down. And that's because in the stratosphere, the wind goes slightly different direction at a different altitude. To provide continuous internet service, you're talking a a complex choreography where thousands of balloons are being steered and programmed all in an automated fashion. So another balloon is coming just at the right time to take its place of the one that left. Our mission control system allows us to track every balloon and lets us optimally position the balloons to provide coverage exactly where the people needing internet coverage are. We can track the location and projected trajectory of every balloon from the moment we launch it, on the way up till it reaches altitude, from the time we decide it's ready to bring it down, all the way down the descent till it's spot on the ground. With our system, we use LTE, which is a common protocol that most of the telcos around the world use. So anyone with a smartphone anywhere in the world will be able to get internet access. One of the key things we do is we partner with the local telco in every country. In New Zealand, we're partnering with Vodafone.
We like to think of ourselves as being very innovative in Vodafone New Zealand, so we thought this was a great partnership. Project Loon allows cell phone companies and internet providers to provide an internet to communities that don't have it. Ultimately, the goal of any internet service provider is to have 100% geographic coverage and all the capacity and speed that people expect. Project Loon will help deliver that.
If you look at the system today, it's amazing how much more advanced it is, from being 10 times higher data rate to the balloons lasting over 10 times as long, to the steerability of the balloons. We've flown in the tropics, we've flown in the Arctic regions. The technology is working. We're getting close to the point where we can bring the internet to people around the world.